Good morning and welcome to Integrated Math 2. Today we are covering the chapter 4 note page, the page 2. So starting with number 7, we're going to be given some right triangles and asked to solve for a side or an angle. So on 7, they're asking us to solve for x, which is this side right here. And it's opposite that 90-degree angle. So I'm going to go ahead and label it the hypotenuse. The other side that's labeled is this 14 right here. And from that given angle measurement, it is the opposite side. So when you look at the three trig functions, the one that uses opposite and hypotenuse is sine. So if you come up here, I'm going to use the sine of the 59-degree angle and set it equal to the opposite, which is 14, over the hypotenuse, which is the x. Then I'm going to go ahead and make that sine of 59 into a fraction by putting it over 1. And that gives me a proportion. To solve a proportion, you use something called the cross product. So for the cross product, I'm going to multiply the sine of 59 times x. That gives me the left side of my equation. Set that equal to the 1 times the 14. Then you're going to use your calculator to get the decimal approximation for the sine of 59. If you don't have a scientific calculator on you, go ahead and go to Desmos. Go to your tools, find your scientific calculator, and there should be a sine button. So we're going to get the sine of, what was it? I think it was 59. Yeah, sine of 59. Oop, I'll type it in the parentheses. Sine of 59 is 0.8. I'm going to round it to 0.857. So I'm going to have 0.857x equal to 14. Divide both sides by the 0.857. And the answer is 16.34. So the length of the hypotenuse is 16.34. Jumping over to problem 8. So again, a right triangle, solving for the side with the x on it, which is again the hypotenuse because it's opposite the little box. And then from the angle indicated, the 20-degree angle, this side that's labeled 29 is the adjacent side. So the trig function that uses adjacent over hypotenuse is cosine. So we're going to say that the cosine of 20 degrees is equal to the adjacent, so I plugged in the 29 there, over the hypotenuse, which is x, made it into a proportion again. So we solve by doing the cross product. And we have the cosine of 20 times x on the left and 1 times 29 on the right. I changed the cosine of 20 into a decimal, and it came out to 0.9396. So I divide both sides by that, and I get 30.86. All right. Jumping down to question number 9, it says, a woman standing 5 foot tall measured the angle of elevation to a frisbee stuck in a tree at 32 degrees. She is currently standing 40 feet away from the tree. How high is the frisbee? So I drew this beautiful tree right here, as you can see. And this little blue thing is the frisbee stuck up in the tree. And here's my little woman. She's 5 feet tall and she is 40 feet away from the tree. And we want to know how tall is that tree. So if her angle of elevation is 32 degrees, we're going to need to figure out which trig function to use. So the tree from that angle right there is opposite, so I call that x. And right next to her, from her to the tree, is 40 degrees, that's adjacent. So I'm going to use the tangent. I'm going to say that the tangent of 32 degrees is equal to the opposite, which is x, over the adjacent, which is 40. I make my tangent of 32 over 1 to make it into a fraction. So I have my proportion, and I solve a proportion by doing the cross product. So I'm going to multiply 1 times x to get 1x, and then 40 times the tangent of 32. And then I calculate that on my calculator. Just make sure your calculator is in degree mode. So 40 times the tangent of 32 is 24.99. That you want to take that though and add the woman's height. So she's 5 feet. So if you add the 5 feet back in, that frisbee is up there. It's 29.99 feet. Okay. Jumping over to number 10. So the base of a 12-foot ladder is placed 6 feet from a wall. What is the angle formed by the ground and the ladder? Okay. So here's my 12-foot ladder. That's this side here. I just label it with a 12. It's the hypotenuse because it's opposite the right angle. And the base of it is 12 feet from the wall, so that's going to be my adjacent side. And we want to know this angle in here, this angle formed that's between those two. So which trig function uses adjacent and hypotenuse? That would be cosine. So we're going to say the cosine of x equals 6, which is the adjacent side, over the hypotenuse, which is 12. Then we're going to solve that proportion by using the cross product. So 12 times the cosine of x equals 1 times 6. Divide both sides by 12. And then we're going to use inverse trig. So you're going to have to either hit shift or second on your calculator and then type in cosine and then 6.2, which is, 6 divided by 12, which is 0.5. And then your calculator is going to tell you that it's 60 degrees. So this angle right here is 60 degrees. That's going to make this one over here 30. All right. Number 11, they want us to simplify all these expressions here. So we're looking at properties of exponents. So we're going to take everything in this parentheses and take it to the power of 3. So I'm going to take the negative 4 to the power of 3. I put that in the first parentheses. Then we're going to take the x squared to the power of 3. So that's x to the second to the third. And then we're going to take the y to the fifth to the third. So that's y to the fifth to the third. Then we just simplify. So if you punch in negative 4 to the third power in your calculator, you should get negative 64. And if you have x to the second to the third, those multiply and you have x to the sixth. And then y to the 5 to the third, those multiply and you get y to the 15th. So simplified, it's negative 64 x to the sixth, y to the 15th. All right, the second one. This one's a little different. This one is not a power to a power. This one is just multiplying. So 3 times negative 4, that's going to get us this negative 12 right here. And then x to the third times x to the second, you actually end up adding those exponents. So you have x to the fifth. And then for the same basis of y, you have y to the negative first times y to the negative third. So when you add those, you get y to the negative fourth. Well, you can't have a negative exponent, so you have to move that y to the fourth to the denominator and make the exponent positive. And then the other parts of the expression can stay right where they're at. So the negative 12 stays, and the x to the fifth stays in the numerator, and the y to the fourth moves down to the denominator. All right, so this last one, I just saw right away that I could reduce the 4 and the 12. 4 goes into 12 one time, and 4 goes into 12 3 times. And then the a to the negative third, I wanted to move that down to the denominator, so I'm actually going to add that to the one exponent that's already there that you can't see. Okay, so 1 plus 3, that's going to get us a to the fourth into the denominator. And the b to the 10th is just fine. It's going to stay right where it's at in the numerator. And then make sure you write that 3 down there in the denominator. All right, and the last question you guys can go ahead and skip. You don't need to do number 12.